So the last example was all about solving a quadratic inequality with two variables, x and a y. Here we're going to talk about solving a quadratic inequality with just one variable. That means it only has x. Well, the nice thing is we can like uh, so x squared plus 2x plus 1. Let's say that's greater than or less than 0. Oh, you can't really see that because I wrote it behind my camera. There we go. All right. So one thing we can always do is graph this, right? Let's just graph the function y equals x squared plus 2x plus 1. Once you graph that, that's going to give you some sort of quadratic like this, right? And at some point, it crosses the x-axis. And the idea is there's three regions to the x-axis now. There's to the left, there's in between, and there's to the right. Now either your solutions are going to be in between to the left or to the right, and you just have to figure out which one it is. You can kind of think of, I call it a projection here, because I'm going to highlight this blue part here. If the answers are between, it's like that blue part of the graph is getting shoved down onto the solutions on the x-axis. Whereas if it is like the pink part of the graphs here, it's getting shoved down onto, let's try another color here, green. It's getting shoved down onto the green parts of the axis. So it's just going to divide the axis up into three parts, and you just got to figure out which one of those three it matches. Now they do have a table that helps you. You can see it here on the screen. This is in your book as well. I can't remember what page, but I imagine it's like 298 or something like that. Where was this last picture? I don't remember it. It's near the end of, it's in this section. You can flip through and find it. Basically the idea is, if you've got a standard form quadratic, a is positive, and it's, so it's a greater than, a is positive, so this is the less than, a is positive, yep. So I got this kind of shape here. That means for this quadratic that I just randomly made up, the answers are going to be in between the two roots. All right. Now, one thing is, it's really good that it's between the two roots because we can find the roots very easily, right? All we have to do is solve the quadratic. We can factor it, we can do completing the square, we can do quadratic formula. We just set it, the quadratic equal to 0, right? And then we can find our answers. Now a very important thing here is if you notice, the solutions are compound inequalities. So you can see here, if I have a positive a value and it's a less than relationship with the 0 on the right, it's going to be an and inequality. If I have a negative a value when x is with a less than symbol, 0 on the right, it's going to be an or inequality. And if I have a positive a with a greater than sign of 0, it's going to be an or. And you can see here, if I have a negative a value and a greater than 0, it's going to be a and inequality. A very important thing here to notice is, you saw that I drew it here, because it's a less than or a greater than, but not an or equal to, I have open dots. You do have to pay attention to that because it's going to include, if it's an or equal to, it includes the roots. If it's not an or equal to, it does not include the roots. So pay attention to whether it's an equal to or not. So, or that, don't include roots. If it's a less than or greater than or equal to, include the roots. All right. Let's try to put this to practice here. Example 2. Solve ax squared plus bx plus c is less than 0 by graphing. So I'm going to look here. My a value is 1, and that is greater than 0. And I have a less than 0. So looking at those two things, I'm going to go back to my chart real quick and see which situation I should expect for my answer. So the whole equation is a less than 0, and the a is positive, so I should come across this kind of scenario. I expect my answers to be in between the two roots. So let's solve it by graphing real quick. So I'm going to graph y equals x squared plus 2x minus 8, x plus 1 squared minus 7. So let's draw my graph here real quick. Sorry, I just completed the square very quickly in my head. You can double check it. Take 2, divide it by 2, square it, it's 1. Oh wait, no, so it should actually be, we add 1, so we subtract 1, that actually should be minus 9. Minus 9. So negative 1, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The intercept is negative 8. So now I got to figure out where the roots are. Well, the roots, all I have to do is set that equal to 0 and solve for x. Add 9 to both sides. Take the square root. Subtract 1. So it's what? Negative 1 plus 3 is negative 2, and negative 1 minus 3 is negative 4. Sorry, plus 2 and negative 4. So positive 2 and 1, 2, 3, 4. I can even double check. This is my axis of symmetry. 1, 2, 3. 1, 2, 3. Yeah, they're both 3 points away. So we're good there. So there's my graph. And now I expect the solutions to be in between, so pick an x value that's in between. How about negative 2? Negative 2 squared plus 2 times negative 2 minus 8, and that should be less than 0. 4 minus 8 is less than 0. Well, yeah, negative 8 is less than 0, so that checks out. So my solutions are in there. So now my solutions are going to be between negative 4 and positive 2. That's where all my solutions exist. So my final answer, I will say x is between negative 4 and positive 2. I don't have the or equal to on there because I do not have an or equal to here in the original equation. Here we go.